What'd you guys get? So I here will be 2, right? M plus 1 factorial. Does that make sense? If you plug in n, you should plug in for the m plus 1. Yeah, it's 2 times n, but you replace the n with n plus 1. Does that make sense? Over m plus 1 to the 5th, absolute value of 2n factorial over n to the 5th. Limits as n approach infinity. So therefore, you will have 2n plus 2 factorial over n plus 1 to the 5th. N to the 5th over 2n factorial. Is this okay?
Yes.
So then you will have, you want to change this to 2n plus 2, 2n plus 1. 2n plus 2 times 2n plus 1 times 2n factorial over n plus 1 to the 5th times what? 2n factorial. So this will, wait, hold on a second, so this is gonna cancel out. And this n to the 5th, right?
Yeah.
Sorry, I forgot the n to the 5th. So then, so make sure that this, you're gonna substitute n, n's n plus 1, so it will be 2n plus 2 factorial. Yeah.
You factor out 2, then you have...
No.
No?
No. 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 You cannot take out 2. Imagine a number, right?
It's the same thing.
Wait.
But that becomes 2 times whatever.
No, it's not. No, it's not. Yeah, I didn't do that for it's not the same thing.
It's 2 times factorial. Let's say it's 2 times factorial. Does not equal to 10 factorial. You cannot take out 2.
Oh.
If it's a 10 factorial, can I take out 2? It'll be 2 times 5 factorial. That will make sense, right?
Yeah.
Yeah, if you write down some term, you will see it.
What he's saying is 10 factorial.
Okay, so this one is going to be n over m plus 1 to the 5th power times 2m plus 2 times 2m plus 1. And this case, when limits n approach infinity, is going to be infinity greater than 1, sorry. So long as it's greater than 1, it's diverge. Are we okay here? Okay, let's recap everything yesterday. Yesterday, we said a function 1 plus the power series is a to the n to the x minus c to the n equal to uh, 0 to infinite is a power series. Yes. N equal to 0, a to the n, x minus c to the n is a power series. The only thing difference between the series now is there is not only a to the n, but there is also x at certain center. It could be center at 0, it could be center at any other value. It could be center at 1, center at 2. And if you have a center, usually based on that center, you have some type of radius of convergence. Radius convergence means that this, so we're going to come up with one of the most easiest series, a power series. This is like this. And we say this is represented by what function? 1 over 1 minus x. Do you guys know why that's equal to 1 minus 1 over x? I think at least I think Ria at the table has some like confusion for us. Why is 1 minus 1 over x? Do you understand why is 1 over 1 minus x? Yeah. A over 1 minus r, right? This is what you're confused about? Oh, the graph. Okay. We're going to show you that in a second. So this is a geometric series. This is an infinite sum of geometric series. Actually, that's funny because yesterday I was helping my son with Algebra 2 competition. I'm training my son to do Algebra 2 competition that you don't know, like, I'm going out. I'm like training kids for pre-calc afternoon yesterday, Alexis Ombi, and then at nighttime I have to train him 2 hours. Train my son is different story. Not like you guys. He's that type of person is not like good at math. Huh?
The older one or the younger one?
The older one.
Oh. Yeah, he put it 6th grade.
But he's better than most of you guys come in than in the calculus at the time. Like his algebra is good, but his reaction speed is just not there, and I was kind of frustrated yesterday. Now sometimes he's not locked in. He's smart, but he's not locked in. He cannot lock in. He can have short-term focus. Okay, so in this case, each term, so at least each term you multiply by something, right? What is each term to the next term? What do you multiply by? X. So the x is the common ratio. What'd you say? So x is common ratio. Therefore, that you can write this with the first term is 1 and 1 minus x because of common ratio. Now, you didn't understand the radius convergence part, right? So the radius convergence part is, imagine that this is an x. You multiply each terms by x. Now, the x has to be within a certain number in order to work. Now, imagine if you have x is equal to 2, then it will be 1 plus 2 plus 2 to the second plus 2 to the third plus 2 to the fourth. That series is easily considered as diverge. Yeah. It would only work if the x is absolute value x or absolute value r in this case, which is common ratio. So absolute value of r is less than 1, or absolute value x is less than 1, because in this case, x is equal to r. And that only works that between 1 and -1. So that means your radius convergence is 1. Okay, yeah, it's 1 unit. But your interval convergence is there is a difference between two questions. One is radius convergence. This is from the center to the edge. It's like me, I'm from the center, I'm going to the edge. That's 1 unit. That's radius of convergence is 1 unit.
Can you show a graph?
Give me a sec.
Oh, I'm sorry.
No. That's what we showed yesterday. Okay. So let if you have 1 over 1 minus x, this is the graph. But if I do the power series representation, will be 1 plus x plus. See, at one point it makes sense. That one particular point makes sense. If I add more point, it will make better sense. If I make more point, it makes better sense. But there is a limitation, right? If you realize it didn't work on anything past 1, because past 1, that is a totally different function. The red function can only represent the black only between certain intervals. That's called interval of convergence. Because anything to infinite, the power series can be not truly represent the function. Does that make sense? The power series cannot represent the function because the series diverge. Okay, so if you keep on adding that at most, at most that you can only be only as accurate as from -1 to 1. So I'm gonna cut this function from -1 to 1 like this using the restriction. It's like this. The only, even you say, okay, I don't know how about the last part. Well, I don't know. We're gonna keep on doing it until it's truly represent. The more iteration I go, the better. Okay, and then matter of fact, I think Anthony told me that I can do, how do I do this again? Summation, right? Summation, we can do a representation, n is equal to 0, this to whatever, but the function is gonna be what? X to the n like this?
Yeah.
X to the n, x to the, how do I do n? N is like this, okay. And let's just say if I do the change the upper bound by 5. Now, if I change this to like 20, if I change this to 200, okay? And if I change this to 2000, it doesn't work. Actually, according to decimals, the radius convergence is not even to 1, but it's only work to -0.75-ish. I don't know why. Maybe Anthony can tell me why. Yeah, but a function, a blue function,
Make it an odd number. Oh, it's probably lagging.
is lacking.
I mean, it looks.
Make it an odd number.
Wait, what do you mean
No,
not
the red is
Yeah,
the one that you made.
It's the blue one.
Wait.
Oh, sorry. You're right. All right, I can't
Yeah,
read.
but like it's completely covered.
It's completely covered. Yeah, it's
That's insane.
That's so weird.
it's 100% matching. So this power series can truly represent the function of 1 over x, but only work because between -1 to 1 because of radius convergence, because of geometric series. Because this function look like geometric series, and geometric series has a restriction of r between -1 to 1. Therefore, radius convergence is between -1 to 1.
So what if your x was less than -1?
Your x is less than -1 doesn't work. It's diverge. Diverge is not going to be represented. Everybody understand this part? Yesterday, we ended the class kind of rush, but everybody understand this part.
Miss of writing
Um,
It's proven.
so a lot of time Well, you gotta understand. Back then, we will talk about this after the thing because we can talk about Taylor series because which is Nathan was talking about silent class in the class. So let's just say if today I want to find out, what's representation of if today my question is and this is on the algebra computation question. It was 1 over 4 plus 1 over 16 plus 1 over 64 dot 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 dot, right? And since this is represented by the function, not only you can think of this, you can think of this, right? X is 1 over 4, so it's going to be minus 1 over 4, and that's the true representation of exact value. We can get approximation too, long as if you have to stop at a third approximation, that's already percentage, how much percentage error you can calculate using the series remainder, but only work with the alternative AST if you have alternating. Okay, you can see how much approximate correctly. Okay, so now what we're gonna do is we're gonna talk about the radius convergency a little bit more. And the radius convergency, you have 3 choices. Yesterday I write down a lot of stuff. I'm gonna simplify it. First, only work 1 point. We usually do ratio tests to test the radius convergence. So we're going to talk about that. So right now we don't talk about interval of convergence. So yesterday I make it too complicated. I write down too many things, and you guys are all like lost at the end. So right now we're just going to keep it simple. Only work at 1 point. That x equal to c. Which is a kind of defeat the purpose that's only worth 1 point. But sometimes that's just the way it is. It doesn't really represent anything else but 1 point.
Oh, like for example, when you just had 1 plus x with that, is that what you mean? Like where only with 1 point were they connected, or no?
No, it's just only you're gonna get correct value only at 1 point. So like the other one is I have an interval between -1 to 1. Sometimes you're gonna get only work with 1 point. That's it. Don't overthink it. Just only that point work. Any other point is gonna be diverge.
But like what like for example, if you compared the sorry, I'm never mind.
Yeah, let me finish everything.
Yeah.
You didn't plug in all the terms. So that's only after you plug in all the terms.
Right.
Okay. Only work 1 point. The second one is probably the best because work all points. Because -infinity to infinity, radius of interval is infinity, even half of infinity, well, half from 0 to infinity is still infinity, so radius is infinity. This one, radius is equal to 0 because there's no radius convergence, it's only 1 point works. The last one is work only at interval between certain intervals. So we're gonna say this is the one that we most concerned about, and with that interval situation. So it'll be x minus c is less than r. So that means if you solve for it, if you know how to solve this equation, this is x minus c. Yeah, less than r and less than -r. That's how you solve absolute value. You set a compound inequality and you plus c on all of them. So it'll be -r plus c less than x less than r plus c. So that means your interval convergence is going to work between -r plus c to r plus c.
R
R equal to C, yes. Now, that's an easy way to determine. You see that is X minus C, then you usually know that radius convergence is going to be how much is center to the edge. You can tell from that term. Now, what we're going to tell you something that I'm going to put in the red notes. AP exam, they really emphasize not only radius convergence, but emphasize if endpoints is converge or diverge. We're going to talk about that later. So we kind of set something you had to prepare for in the future. But endpoint matter too, because sometimes endpoint is converge. Sometimes endpoints diverge. They are very easy tests. All you gotta do is just plug in the original function and see are they AST or they harmonic or they some easy series that you did before. Okay, let's talk about the first one. The first case, I want you to use the ratio test, which is most of the time interval convergence use ratio test. Do you know why we use the ratio test?
Because that's by n equals 0.
Did you?
Oh, sorry, n equal to 0. Do you know why we use ratio test rather than any other test?
Determines if it's decreased.
No.
The student should now be back from A1.
Oh, it's not good factorial.
Because what, Aiden?
You can cancel things.
Well, that too, but it's not main reason. That is a small part of the reason, but that's not a main reason.
Factorial.
No,
The absolute value.
that's also a small part of the reason. What is the main reason? Almost there. Almost there.
It uses
Use the 1.
because we need that for the interval. Oh.
We needed something that's less than 1 to converge. We need a ratio test to be less than 1 because this time it's not geometric series. Right? It's n factorial times x to the n. It's not geometric series. We don't have some compare with, but this, if you use ratio test, you always compare your ratio test the result to 1. So that way we know if it worked. So I want you to use the ratio test on this part. You can simplify it. And then I'll teach you how to do the end part. Just simplify and see what the result you're going to be. And then I'll do the end part for you. You do the beginning part. Okay, just practice some ratio tests.
All collectively do the same thing.
And then that goes from
Okay, so what we're going to do is we're going to do this. n plus 1 factorial times x to the n plus 1 all over n factorial times x to the n. So we can change this to x to the n times x to the 1. Does that make sense? So I am going to cross out this, write that, and I'm going to cross those 2 out. And I'm gonna change this to n approaching infinity. Sorry, don't write it out. Let me not be lazy, so that way you don't get confused. Um, this one's x to the n. This one's x to the n times x. And for this part, I'm gonna do n plus 1 times n factorial over n factorial times x to the n, x to the n. This cancel out, and x. So limits at n approach infinity of n plus 1 times x, right? Now here's the thing. Does n plus 1 matter in this case? Well, n plus 1, since n is always positive, so n plus 1 can be taken outside absolute value. Does that make sense?
Yeah.
So because n is approaching infinity, it start with 1, start with 0, go to infinity, so n is always positive. So n plus 1 times absolute value x. Now what happened if this part, now focus on only on this part. This part is going to go to what? Infinity. X is some type of value we're going to approximate, right? So say we want to approximate is 1/2. But what's infinite times 1/2? Infinity. So this is diverge. Diverge if x is any other number. But converge only if x is equal to 0. Because you have infinity times 0, well, that's kind of indeterminate form, but in this case, that 0 is just a constant. So anything times 0 will be 0. So only one point that will work at x equal to 0, but diverge everywhere else. Except x equal to 0, because x equal to 0 is converge. No, we're not finding out. We just say outside is infinity. Limits n approaching infinity. N plus 1, that's going to be infinity. But we want to see, we want to compare this whole value. Are they less than 1? But you have a infinity times anything. Even infinity times 0.00000000001, it's still going to be infinite. Or negative 0.0001, that's going to be absolute value, infinite. Right? So it doesn't matter what I plug in, but only work if x is equal to 0. Does that make sense? Yeah. Okay. So we're going to talk about a second case. So what's the radius of convergence here? 0. The only work at x equal to 0. That's the first case. We talk about that's the first case, first unique case. Okay? Now that's infinite equal to 0 to infinity of negative 1 to the n to the x to the 2n. Be careful 2n. Every time at 2n, you gotta think about it. If you're gonna plug in n plus 1, that means there's an extra parentheses. That's why it's gonna make you lead to extra mistakes. And I will tell you, because I did them before. I'm not smarter than you are. I learned this 3 years ago with Luke Davis. And Anthony was my guinea pig for the second year. Third year. And you guys still guinea pig. I'm sorry. Because sometimes you're going to ask me a question. I'm going to be honest with you. I'm going to be like, I don't know. But this is the things I make mistake because sometimes I make careless mistake like here. 2n's, especially with deal with 2n's. Because 2n factorial, that's going to be, that parenthesis doesn't distribute like what Jordan assumed or Ethan's assuming. Either Jordan or Corbin, I don't know.
What do you mean? I did the whole thing. I knew it was so right.
Oh, yeah, it was the all. Y'all did. Well, you agreed with it, so this
Yeah. Parentheses. Because now we have Here's n factorial. Wait, what do you mean 2n plus 2? Oh, that's the question. Oh, jeez. That's how it's done for breakfast.
And for you to think about a radius convergence here, it's a little bit difficult, but we can try. But yes, also like I know you guys are mentioning Professor Lender. Professor Lender is great. That's why I get his notes from. Um, and so I'm just a lot faster than Professor Lender. You're gonna watch 3 hour video and make it to like 45 minutes. But if you want to watch 3 hour minute, you have to do speed 1.5. But to give me credit, I'm not Greenwall. I'm not playing on somebody else's video.
Anytime Leonard's got up, Ria's always like, oh my gosh, he's so hot.
Who?
Ria always says that. So does Lyle.
He's hot. Don't deny it. He's hot.
Can you pull up his page? Can you pull up his page? I want to see that. Let's see.
Likes me, not as me. Isabel think he's hot. He's definitely hot skills diverge. Isabel thinks so. Look at her. Look at she's like laughing. We're on a live stream.
So now I have a question. So as long as
All right, so limit limit is gonna go to infinite. Now I'm gonna including the -1 for now, but you're gonna know that when it's absolute value, -1 doesn't matter. -1 doesn't matter. So it'll be 2 parentheses m plus 1 over 2 to the m plus 1 factorial. All over -1 to the n times x to the 2n all over 2n factorial. Yeah, I'm going to tell you because we haven't exercised the negative sign yet. We haven't exercised the absolute value yet. So we should keep the absolute value sign. So once we exercise the absolute value sign, the -1 goes away. So on the top, I'm going to write down x to the 2n times x to the 2. Is that okay?
Yeah.
On the bottom, I'm going to write down 2n plus 2 times 2n plus 1 times 2n. N times 2n factorial times 2n factorial x to the 2n. Now we know what's Ria doing at home now. She's drawing over. All right. 2n factorial cancel out. And x over 2n cancel out. So that becomes 1 over 2n plus 2 times 2n plus 1 times absolute value x squared. Now, limits as n approach infinity. Now, realize we're going to look at this part first. What happens if you look at this part first? 0. But 0 has to times some number. 0 times 0 is fine. 0 times 0. 0 times 0.1, it's square, it's fine. 0 times what is less than 1?
Infinity. It doesn't work.
0 times what? Oh yeah, well, yeah, everything works. I'm sorry. 0 times what is equal to less than 1? So x could work on any value. No.
What? Zeros. It's x. Zero times zero. No, because it's technically being divided, bro.
Wait, hold on a second. Hold on a second.
Because you're technically still doing x squared divided by.
Hold on.
No, bro. He's basically separating it. He's gonna be like,
Doesn't matter. Infinity times zero. I'm only having
Infinity is the bottom of it. It's not divided.
No, hold on.
X can't be defined by infinity. You think about it. Can you solve for
Hold on a second.
when you say infinity, it basically just means all numbers.
Hold on a second.
I'm trying to do some like indeterminate stuff with this, bro. Don't say my name. Say Roger's name, bro.
Okay, so the x is gonna be the radius of convergence is gonna be infinity, right? So it's gonna work from negative infinity to infinity because doesn't matter what value you plug in, it's gonna be divided by bottom's infinity, and so it's going to 0. So this is actually a pretty interesting function. Why is this an interesting function? Why is this an interesting function? Now this function, if I type in on the things, if I just type in this in, right? And we're going to talk about the derivation of this function, but we just type in as where it is. So you guys remember that function, and we're going to type in. So what is the first term?
First term for what?
First term for that power series. What's the first term? X squared?
Yeah.
Negative x squared. But you know, I'm lying.
What are we talking about?
X squared.
X squared is 0.
Okay, x squared.
Where are we going?
No. N equal to 0 first. Right? N is the square with 0, right?
Yeah. It's x squared over 2 factorial, then it's x negative.
It starts at 0.
Do 0 factorial is 1, and the x to the 0 is what? 1. So first term is what? 1, right? First term is a 1, right? First term is a 1, right? And how about the second term? 2. If it's n is equal to 1, so it's going to be by 2 factorial, right?
And it would be negative, right?
You'll be negative. You're right. We are alternating. Thank you. Is this okay? Does this look like something? Not yet. Okay. Plus x to the fourth over what? 4 factorial? Okay, does this look like something?
I don't remember what that expression is, but I know that
Minus x to the 6
Cosine.
over 6 factorial.
I don't think it's
Oops. Plus
What is it?
x to the 8 over 8 factorial.
Even, so it's cosine.
But
It is not.
no, it's not making
Minus x to the 10th over 10 factorial. Plus x to the 12th
Okay. I'm sorry.
over 12 factorial. I cannot talk over you guys. So it looks like is cosine of x, because cosine of x is very accurate for us down to the point. Now you can write not yet. This is the problem when they go to the example power series. It happened to be Taylor series, and this is the Taylor series for cosine.
But it doesn't follow the formula.
It's extra 2n over 2n factorial.
It doesn't follow like the. You know, like the. You know, I don't know if it would be second.
Hey, you know what the problem is?
Infinitely, I think that means right.
You didn't even tell me.
Negative 1 x to 2n over 2n.
So it's like, is it, it's power series, but is it considered Taylor series?
Yeah, because you use Taylor series to prove that this is the power series for the
Oh, okay.
thing.
So like if you simplify it from like,
Nathan, Vincent.
Do you want Elaine to do it?
Like now, let me think. I'm gonna talk to Nathan, Vincent, and everybody, and then you guys decide. I think there's a pros and cons. There's no either way. There is just because I feel bad for how much Nathan practiced, and I take away for him at the end.
Yeah.
That's the first thing. Second thing is I don't know what Anthony think. But Elaine can fill in probably just as much as Veda fill in.
Yeah.
I think maybe sometimes it's slightly better than Veda because I think Veda tended to misread a lot of things. I think Elaine's probably better at certain things. Yeah, she could have failed everything blank. She still got 30 points, but she got 31. So that means she guessed a lot, and then
She gets on 7.
yeah.
she gets on 7 and miss.
We got 2.
You got 2. How come that's
I don't know.
how come that's 31? Oh yeah, 31.
Yeah.
Okay.
You start at 30, you lose out on 7.
So you consider what do you think, Anthony? I don't know. I like those. I'm very indecisive at times. And,
keep this stuff. And then, I mean,
Okay, then we go with Elaine.
what happened to the other? Nine.
She's
Well,
the,
she
her
thought it was
parents.
Olympia, and then I told her that line, she's like, oh my.
That's fair. I mean, that's not. So right now it's not a bad team. Will be Caden, Jared, Anderson, and Elaine if that's the choice. But you know that score, even if you put Nathan, it will probably only be probably 10 to 20 points higher. But I think he might be able to compensate 10 or 20 points
I feel like
compared to Vincent. I don't know. I feel like Vincent's really good, but Vincent prefer it in team two. I think Vincent's good enough team one, honestly, because what he got it right on that trigonometry equation, then you mess up a sign, and I think that he's able to do it just as good as Nathan. I think he could can do just as good as Nathan. So let's go with Elaine. Push. Oh, who's that?
That was Austin.
That's Austin.
Chris isn't here. He's in Orlando.
Okay, let's go with Elaine. Let's go with Elaine because we don't want to ruin the chemistry right now. That's
Yeah,
not a
I
point
think-
right now. So we can sacrifice a little bit and win something a little bit later.
Okay.
Hopefully, we're gonna account that Nathan can catch up the score difference between Elaine.
Sure he can.
Yeah, I think he can.
Okay, fine.
Look, I still look at it and like not something.